Today we're going to be talking about inverse functions. So what an inverse is it undoes a function. Undoes a function. And we use inverses a lot without actually realizing it. Like when we subtract something from both sides because we see x plus 3. We subtract 3 from both sides. That's inversing. That's the inverse of addition when we subtract something from both sides. Like if we want to do the inverse of addition, we do subtraction. You can think about it, if you wrap a present, the inverse of that is unwrapping the present. If you have an ordered pair, x comma y, the inverse of that would be y comma x. So you're just switching the x and y values. So we're going to use this in example number 1. So we're going to consider the function below with that table, and then we're going to create the table for, in this symbol right here, this means inverse. So it means inverse of f of x. That's what that -1 means, where that exponent would normally go. So let's look, and all we're going to do is we're going to switch the x and f of x value. So instead of -3 comma 12, it's going to be -12 comma -3. Instead of -2 comma 10, it's going to be -10 comma -2. So we're just going to go through and switch the x and f of x values. Whoops. So -2 comma 2, 0 comma 3, and 2 comma 4. So then we're going to graph both functions. Well, if you look at the top one, you see the y values are going up by 2. So m is equal to 2, your slope. If you look at the bottom one, you might think, oh, your slope is going up by 1. Oops, by 1. But you also have to look at your x values. Look at the x values are going up by 2. So your slope for this one is actually 1/2. Because every time, as we move from left to right on the table, my y values go up by 1, but my x values go up by 2. So that's why I wrote the slope as 1/2. So let's plot these points here. So -3 comma -12. So that's going to be off the graph a little bit. -2 comma 10. So I'm just plotting all of these points here. Oh, whoops. $11. So there's 11 boxes here. Okay, so here's f of x is right there in pink. And then in purple, I'll graph the inverse. So -12 comma -3 will be right here. -10 comma -2, -8 comma -1, -6 comma 0. So I'm just going to be graphing this. Okay. So we graph both functions. What do we notice about them? Well, both slopes are positive. They're both going up and to the right. Both slopes are positive. The slopes are also reciprocals. And remember, reciprocal is when you flip the fraction. So slopes are reciprocals. And that's when you, again, flip the fraction. And also, from geometry, you can look at this and say, well, that looks like we have a reflection. In geometry, when we reflected over the line y equals x, you may remember that all we did was switch the x and y coordinates. When I would give you a point or a shape and I would say reflect this over the line y equals x, you just switch the coordinates. So this is a reflection over the line y equals x. Okay. So now write the equation of f of x. So write the equation of my original function in pink. Well, my y-intercept is -6, you can see from the graph, and your slope again was 2. So f of x is equal to 2x minus 6. And then letter D is asking us to find the inverse algebraically. So we're going to write out the steps and then do each step. So the first step is going to be replace f of x with y. So y equals 2x minus 6. My second step is going to be switch x and y. And that should make some sense because, like we just discussed, back in geometry, when we reflected over the line y equals x, we just, again, switched the x and y coordinates. So it would make sense that if I want to solve or find the inverse algebraically, well, we should just switch the x and y coordinates. Sorry, switch where x and y are. So x equals 2y minus 6. And then step 3 is going to be get y by itself. So we started with x equals 2y minus 6. So we're going to add 6 to both sides. X plus 6 equals 2y. Divide everything by 2. We get x over 2 plus 3 equals y. And then the last step, and this is an easy one to forget, is you're going to replace y with the inverse notation. So then it will read the inverse of f of x is equal to x over 2 plus 3. So you really need your algebra skills to get to be able to do this and to get the correct answer. But it's very simple. You're just going to switch x and y and then get y by itself. Now, example number 2, consider the function g of x equals x squared minus 4. We're going to find the inverse. Now, in problems like this, you may see an additional part of the directions that will say x is greater than or equal to 0. And we'll talk about that in a second. So we'll have y equals x squared minus 4. Then you're going to switch x and y. So x equals y squared minus 4. We're going to add 4 to both sides, so we get x plus 4 equals y squared. And then we'll square root both sides. And we'll get the square root of x plus 4 equals y. And then your inverse would be inverse of g of x equals the square root of x plus 4. So you may be thinking, well, why don't we use plus or minus? Yet we're not solving an equation. So we don't really need to worry about the plus or minus as much, and especially since we have that part right there. Again, the reason why we have that, or any number, it could have been x is greater than -4, something like that. The reason we have that is because you can't take the square root of a negative number. This is restricting our domain to say, all right, x has to be greater than or equal to -4 or 0 or any number that you see up there. That's just extra information to say that you can't take the square root of a negative number. So this is our inverse right there. All right, so now we're going to graph both of these. And you may be thinking, well, I don't know how to graph a square root function or anything like that. That's okay. We know how to graph the quadratic function, and we know we can just switch the x and y values. And if all else fails, you can always make a table. So let's make a table. Okay, so x, y, and I'm going to start my x values at 0. And the reason for that is because up here I said x is greater than 0. So I'll start there. So let's call this g of x so we know which table we're talking about. So when I plug in 0 to my original equation up here, g of x, that is going to give us -4. If I plug in +1, +1 squared minus 4 is going to give us -3. If I plug in 2 squared is 4, minus 4 is 0. And if I plug in 3, I will get 5. So we can use that information to make a table for the inverse, because the inverse will just have a switch the x and y coordinates. So it's going to become -4, 0, -3, 1, 0, 2, and 5, 3. So we can graph each of those. So let's go ahead and graph the blue one. 0, -4, 1, -3, 2, 0, and 3, 5. So this one is going to go up like that. Now, for the one in black, we'll graph that -4, 0, -3, 1, 0, 2, and 5, 3. So let's find the domain and range of these functions. The domain of g of x, so the domain of the blue one. The x values start at 0, and the x values could keep going up. And that means we're going to go all the way to infinity. Now, the range, the y values. The smallest y value we have is right here at -4, and the y values are going to keep going up to infinity. Now, if we look at the domain and range of the black function, my inverse, well, you see the smallest x value we have is right here at -4, and the arrows keep going forever. My x values keep going. So we go to infinity. The range, the smallest y value we have is right here, and that's at 0, and we go all the way up to infinity. Yes, the x values in my inverse, in my black line, the x values go up faster than the y values, but the y values are still going towards infinity, just slowly. So then you may notice, wait a minute, the domain of g of x, my original, is the same as the range of my inverse. And the range of my original is the same as the domain of my inverse. And if you really think about it, that should make sense. Domain is your x values and range is your y values. And if I just switch my x and y when calculating the inverse or even plotting the points for the inverse, well, then that should make sense that the domain and range should switch as well, because the x in my original function becomes the y in my inverse. So let's look at our last example. We're going to consider this function. First, it says to find the inverse. So y equals 8x to the third. We will switch the location of x and y. So x equals 8y to the third. Then we'll divide both sides by 8. And we get x over 8 equals y to the third. And then we're going to do the third root to both sides. So on the left side, it's going to be the third root of x on top over the third root of 8 on the bottom equals y. Well, the third root of x will just stay the third root of x. However, the third root of 8 is 2. So that makes our inverse, the inverse of h, is equal to the third root of x over 2. So when we graph that, and yes, we haven't graphed a cubic function or a third power function before, but we can still make a table for that. So I'm going to make a table. So x and then h of x, and I'm going to use -2, -1, 0, 1, and 2. So I'm going to plug those x values in for h of x, my original function. So when I type those into the calculator, when I plug in -2, I get -64. When I plug in -1, I get -8. When I plug in 0, I get 0. And when I plug in 1, I get 8. And when I plug in 2, I get +64. So now when I make my inverse table over here, I'm just going to switch my x and y, -64, -2, -8, -1, 0, 0. That one was easy to switch. +8, +1, +64, +2. So yeah, when I graph these, I'm not going to be able to graph all the way down to -64. So for my graphs over here, I'm just going to plot these 3 points. And for the inverse, I'm just going to plot these 3 points. Oops. That way, they'll all fit on the graph. So in blue, -1, -8, 0, 0, and 1, 8. So this will look almost like a line. And in yellow, -8, -1, 0, 0, and 8, 1. So this one, again, kind of look like a line. So then the domain and range. Well, if we just find the domain and range of the original h of x, then we know we can just swap them to find the domain and range of the inverse. Well, if you look at the graph, the x values go on forever. Yes, again, the y values are going up much faster. However, the x values are also going up. So your domain is -infinity, infinity. And your range is also -infinity, infinity. So let's swap these and get our domain of the inverse, which is going to be -infinity, infinity, and the range, which is also going to be -infinity, infinity. So the big idea with inverses is that you're switching x and y. And when you switch x and y, there's a lot of things that become easier, like finding the domain and range of our inverse becomes easier. Calculating the inverse by switching x and y and then solving for y. So that is our big idea here, is we're just switching x and y. So I hope that this was a good introduction to inverses. Thank you for watching. Make sure to like and subscribe.